Hi there, this video is about how to do box 1 and 2. So let's tackle box 1 and 2. Oh, I'm sorry, this is box 2 and 3. That's on your worksheet. Okay, so if you're looking at box 2, this is when you're using your ruler. So this is when you've got the two test tubes. And let's say you had the solution that was blue, you had the darker one that was here, and then this taller one was kind of the lighter blue one. So this one here was your diluted solution, and this one here was your stock solution. So when we're in the lab and we want to measure, like use experiments to determine what is the concentration of my diluted solution, it's trying to find the concentration. What you're trying to find is the molarity. So to do that, you're going to take your stock solution, that'll be this side, and your diluted solution will be on this side. So my stock solution here, I'm going to say I measured it, and my distance for that is 2.12 centimeters. 2.12 centimeters is what goes here. You want to check out your green sheet that's posted online, and it's got the equation on there. But we're going to basically be looking at distance times its concentration or molarity equals the molarity times the distance. So the molarity of my stock solution when I did this lab is I had a 0.98 molar solution. So that was what you were assigned for the molarity, whatever you were assigned to make. Then on my dilute side, my dilute part, this distance here was a total of 7.42 centimeters. 7.42 centimeters. And I want to find what the molarity of my dilute solution is. So I'm going to push numbers in my calculator, boop, 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 and my calculator gets that question mark, or I'll call it X, is equal to 0.28 molar, or molarity is 0.28. So that's how we measured it in the lab. So this is going to be what our experimental values are. And box 3 is where we calculate theoretically what should my solution have a concentration of. So for this, it still also has a set of parentheses. This side here will be my stock side, and this side here will be my diluted side. So for that, the equation for it is M1V1 equals M2V2. So my M1 is the molarity of my stock solution. Like I said, I was assigned to make a 0.98 molar solution from the start, so you'll have to look for that. The V1 is the volume that you used when you tried to dilute it. So that's when I had you take 6 milliliters of the solution and pour it into a test tube. So this is 6 milliliters. And then on my dilute side, this is what I want to find, my M2. So I'm going to call that M2. Now, according to my lab, it should be 0.28, but I'm looking at theoretically should be that. We know labs always have errors, so theoretically, if everything went perfectly, what should my molarity be? And then my V2, the V2 is the total volume that you had. Remember, I had you take 17 milliliters of water and add that to the 6 milliliters of the stock solution. So 17 plus 6 gets me 23 milliliters. 23.00 to be sig fig correct, so 23.00 milliliters. So that in the end I can calculate my M2 from here. My M2 ended up being 0.26 molar using this equation. So right there you can see that theoretically I should get 0.26. When I did the lab where I used my eyes and saw the depth of the solution, I got 0.28. Pretty darn close. And if I calculate my percent error, I get a 7.7% error. And that's what you're going to do in box 4. So I hope that helped.